Okay, so for this lesson, what we're going to look at is elements. And then we'll relate this back to the periodic table and the way that that is structured. Basically, elements are made up of one type of atom. Okay, so everything that's the same element will have the same number of protons in its nucleus. So, for example, if we're looking at carbon, um, carbon's only made of carbon atoms and they all have 6 protons in their nucleus. If we're looking at oxygen, that's all made up of oxygen atoms. They all have 8 protons. So effectively, an element is made up of one type. And what we know of in the universe is there are 118 known elements. Some of the ones down the bottom of the periodic table, we have a look at it. The ones along this bottom row generally don't exist in nature. Most of these have been made in laboratories. You'll see on your periodic table that they all have names. Some of these referred to as UUT, UUP. That was what they were named when they were created. The periodic table basically lists all of our elements in an order of increasing atomic number. So 1, 2, 3, 4, etc. So what we're doing is we're increasing the number of protons as we go left to right, and then work our way down. It is a bit weird that there are these gaps in it, but as we go through and we start to look at different groups and valence shells, hopefully that'll make a bit more sense. Um, there are a few specific groups that you do need to know on the periodic table. So we have put in the metalloids, we have talked about metals and non-metals, but on the blank periodic table I've given you in class, I do want you to do a little bit of colouring again. So there are some specific groups that I want you to know of. So if we start at the left, so hydrogen being excluded because it's a non-metal, this first column, or group 1, is what's called the alkali metals. Okay, so you can colour that in a particular colour. The second group is what is called the alkali earth metals. Now, the main difference between them is these guys are super reactive, these guys are less reactive. These ones in group 1 don't exist as clumps in nature because they effectively react with water, whereas these guys are less reactive and we can actually find them. This big group, which is 10 wide in the middle, so going from scandium across to zinc and down, they are what are referred to as our transition metals. We've then got two specific groups of non-metals we need to know of. The N group is what is called our noble gases. They are ones that have a full valence shell. They're non-reactive, so they just exist in nature and are pretty happy on their own. And then we've got halogens down here, which are our most reactive non-metals. So if you can colour in that blank periodic table and do a key up with those key groups, I mean, the rest again, you've just got non-metals here. These are just metals. These ones down the bottom are your actinides and lanthanides. We won't really deal with them through this topic though. The other thing you need to know about are what are called periods and groups. So periods are effectively your rows. Okay, so there are 7 periods on the periodic table. They're very useful for figuring out electron configuration. Basically, the period that an element falls in is the number of electron shells it has. So, for instance, if it falls into period 4, it's got 4 electron shells. 3, 2, 1. You won't deal with anything below 4. We also have our periodic table broken up into groups. There's 2 ways of numbering it. So there's an older numbering system, which we generally use electron Roman numerals for. So 1, 2, we skip the transition metals, 3, 4, 5, 6, 7, 8. That's really helpful actually because that allows us to know how many valence electrons there are. So everything in group 1 has 1 electron in its outer shell or in its valence shell. Group 2 here by the old system has 2, 3, 4, 5, 6, 7, 8. Okay, so that's actually really helpful when we start doing ions and things like that too. The more common one that we use though is just going 1 to 18 across, where we include the transition metals. So what we can actually do is we can sort of give a bit of a location periodic table for an element. So if I'm looking at sodium, it's in period 3, group 1. Now what that tells me is it's got 3 occupied electron shells. Okay, so I know that number 1 is going to be full, so it's going to be 2. Electron shell 2 is going to be full, so that's going to be 8, so it's going to be 2, 8. And then my third one, because it's in group 1, has 1 valence electron. And it actually, yeah, it's kind of useful for figuring out valence electrons through there. There is a video just on a bit of the history of the periodic table I'd like you to have a look at as well. You don't need to note it, but it's just really interesting because it sort of shows how Mendeleev came up with the periodic table, how he was able to predict elements. So that's linked into Sector. If you can have a look at that one as well, that would be great.